Welcome to the Joy of Architecture. This is where we take a stack of source material, dive deep, and pull out the crucial insights to get you well-informed, fast.
That's right. And today we've got a really interesting collection. It's all about one of the big debates in modern front-end development, especially when things get big.
Yeah, we're tackling the architectural showdown, SBA single-page application versus SSR server-side rendering. But crucially, we're looking at it through the lens of microfrontends. How does this choice play out when you're building those complex multi-part systems?
It's super important because microfrontends, or MFEs, have really taken off as a way to handle complexity in large web apps. Think of it like microservices, but for the UI. You break down that big monolithic front end into smaller bits that teams can build and deploy on their own.
Exactly. Big names like Spotify, Zalando, they build this way. It's driven by the need to scale, not just the tech, but the organization, right? Giving teams autonomy, independent deployments.
Totally. Especially when you've got lots of teams working on one huge product, or maybe a whole suite of products.
And the sources really stress this isn't just code architecture. It's socio-technical. It reflects, or even shapes, how teams are structured. Conway's law in action.
Yeah, that connection's fascinating. Some companies even flip it, reorganize teams first to match the MFE structure they want. The inverse Conway maneuver.
Wild stuff. Okay, before we dive into the actual debate, let's quickly define our terms. SPA, what's the gist?
So basically, with an SPA, what you get first is just a minimal HTML shell. All the real action, the rendering, the navigation, happens in the browser using JavaScript. When you click something, it doesn't load a whole new page from the server. Instead, the browser intercepts it, grabs data if it needs to, and just updates parts of the page you're already on.
Giving you that smooth, app-like feel after it loads initially.
Exactly. That's client-side rendering, CSR, doing the work after that first shell.
Gotcha. And SSR.
The SSR flips it. The server does the work up front. For each request, it builds the full HTML for that specific page.
The whole page.
Yep, the whole page. Sends that down. Then JavaScript takes over on the client in a process called hydration. It basically wakes up the static HTML, makes it interactive.
So client-driven versus server-delivered. Why is this choice so fundamental when you add microfrontends to the mix? It seems like just a rendering detail.
Because you're not just rendering one app anymore. You're stitching together multiple independent apps, the MFEs, into one experience. And whether you do that stitching on the client, SPA, or the server, SSR, changes everything. Performance, SEO, developer workflow, the user experience, it all hinges on that composition choice.
And the sources suggest that just mixing and matching rendering freely across MFEs is usually asking for trouble. Too complex to integrate smoothly.
Pretty much. You generally land on one dominant strategy, SPA first or SSR first, or maybe a really carefully planned hybrid model where that composition happens browser or serverage. That's like the central pivot for the whole MFE system design.
Makes sense. And just to be clear, for this deep dive, we're focusing on those really big systems. Multi-team, multi-product, where things like independent deployment, maintainability, performance at scale, developer productivity, and just keeping the whole thing running reliably are the top concerns.
Exactly that context.
Okay, let's get into the core clash. It sounds like these aren't just technical choices, but almost different philosophies for building these large MFE systems.
Absolutely. You've got the SPA advocates who see SPAs plus MFEs as like a match made in heaven, their core belief. SPAs are naturally decoupled. They promote team autonomy, and that's perfect for building scalable front ends where teams can own their piece.
Autonomy seems key there. What's the argument?
It's all about independence. Each MFE is its own little SPA, right? Often just static files, HTML, CSS, JS teams can build and deploy these static assets completely independently, maybe just pushing to a CDN. No big central server build needed.
Which fits nicely with independent CI/CD pipelines?
Totally. And it gives teams flexibility. Want to use React for this MFE, Vue for that one. Client-side composition makes that easier, theoretically. Plus, once it's loaded, navigation feels fast. That app-like experience kicks in.
Okay, so freedom, flexibility, speed after the first load. Makes sense. But what's the counter-argument from the SSR camp?
They'd say, hold on. For large systems, especially public-facing ones like e-commerce or content sites, SSR plus MFEs gives you better initial performance and much more reliable SEO.
So their focus is speed up front and discoverability.
Exactly. SSR gets meaningful content, HTML, to the browser fast. That means quicker first paint, better LCP scores, metrics that really matter for user engagement and perceived speed. And because the content's right there in the HTML, search engines can easily understand it. That's often non-negotiable if you rely on organic traffic.
And in an MSE context, SSR helps with consistency.
Yeah, the idea is that composing on the server gives you tighter control. You can ensure headers, footers, overall layout are consistent across all the fragments being pulled together. It's easier to manage that central look and feel.
Okay, so SBA camp, autonomy, subsequent speed, SSR camp, initial speed, SEO, consistency. Two different sets of priorities driving the choice. And that difference in priorities must directly shape how the architecture works, how you actually piece the MFEs together.
For sure. With SPAs, composition happens client-side, in the user's browser, usually of a main shell application. Its job is to figure out which MFE to load, when to load it, mount it, manage its lifecycle, all happening at runtime.
And tools like Single SPA help with that orchestration.
Exactly. Single SPA is designed for that client-side routing and MFE mounting.
And Webpack Module Federation. That comes up a lot.
Module federation is huge here. It lets separate builds like your shell and your different MFEs share code dynamically at runtime.
So like sharing React or a big design system library without downloading it multiple times.
Precisely. In a complex SPA MFE system, that's critical for keeping bundle sizes reasonable and performance decent. It enables that client-side composition to scale.
So client-side composition enables the independent deployment and tech flexibility.
Right. Static assets to a CDN means independent releases. And the browser environment is generally more forgiving if one MFE is React and another is Angular, if managed carefully.
What's the catch with tech flexibility? You mentioned theoretically.
Well, if you don't manage it, you could end up forcing the user to download React and Angular in Vue. Bundle sizes explode. That's where module federations sharing or strong governance around shared dependencies becomes absolutely vital. Flexibility needs discipline.
Okay, clear. Now, shifting to SSR, where does the composition happen?
On the server, or increasingly at the edge closer to the user, you have some kind of UI composer service, an orchestration layer. It gets a request, figures out which MFEs are needed for the page, fetches content or markup from their backend services, and stitches the final HTML page together.
Using things like ESI, or maybe custom solutions like Zalando's Tailor.
Yeah, or reference architectures you see from cloud providers. There's a central point doing the assembly before it hits the browser.
And that central assembly point is key for ensuring consistency.
It makes it much easier, yeah. Applying global headers, footers, styles, maybe injecting some initial shared state that you can enforce that centrally before sending the page down.
But what about consistency after the page hydrates and becomes interactive?
Yeah.
Can it still feel fragmented if the MFEs don't follow shared patterns?
Oh, absolutely. SSR gives you a consistent initial render, but if the hydrated MFEs behave wildly differently, the UX can still suffer. You still need strong design systems and governance, regardless of server or client composition.
Got it. And that central control point also helps SSR nail the initial performance and SEO goals.
Yes, because you control the whole rendering pipeline there. You optimize fetching, fragment rendering, assembly, and crucially, you deliver that full, content-rich HTML directly to the browser and the search crawlers.
Okay, so composition happens client-side for SPA, server-side for SSR. What are the main architectural criticisms each side throws at the other?
SPA folks will point to SSR's complexity, especially around hydration. Making sure all those independently developed MFE fragments hydrate correctly and consistently on the client can be tricky. Debugging server-side rendering issues adds overhead, too.
And the SSR counter-critique of SPAs.
They worry about the browser becoming this complex, potentially fragile integration point. They argue that maintaining a consistent UX, achieving reliable initial performance, and nailing SEO across potentially dozens of independently deployed SPAs without that central server control is really, really hard.
So it boils down to where you want to manage that inherent complexity, distributed in the browser or centralized on the server. Right? Complexity management is one thing, but users feel performance directly. How does this SPA versus SSR choice impact speed in MFE systems?
With SPA-based MFEs, a potential plus is lower server load, because a lot of the rendering work is pushed to the client's browser. Serving static MFE assets from a CDN is usually cheap and scales well, and the big win is that subsequent navigation speed. Once the shell and initial bits are loaded, clicking around inside the app feels really fast, no full page reloads.
That's the key user benefit, right? But the catch is the initial load.
Definitely. That's the weak spot. The browser has to download the shell, maybe large shared libraries, and the JavaScript for the first few MFEs. That can mean multiple network requests, lots of JS to parse and execute, all before the user sees much. It hurts those first contentful paint, FCP, and largest contentful paint LCP metrics. And even if content arrives early, the hydration process itself can chew up CPU on the client, delaying when the page is actually interactive, especially on less powerful devices.
Okay, so SPAs often trade slow initial load for fast subsequent loads. How does SSR fare on performance?
SSR's strength is that fast initial paint and LCP. Delivering pre-rendered HTML means the browser can show something meaningful much faster. Great for perceived speed, great for SEO rankings.
But it has its own performance challenges in an MFE setup.
Oh yeah. Caching those server-rendered MFE fragments effectively is notoriously hard. You have fragments coming from different services, potentially with different data freshness needs. Cache invalidation becomes a nightmare. And the server-side orchestration step itself adds latency. Fetching data, rendering fragments, stitching them together, that all takes time. If not optimized, that central composer can become a bottleneck, slowing down the whole response. I read one account where their complex SSR setup actually made the first load slower than a simpler approach. It's not automatically faster. Implementation matters hugely.
Wow, so the central control can backfire. Are there ways to tackle these performance issues for both sides?
Absolutely. For SPAs, smart teams use aggressive code splitting breaking code down by route or MFE, lazy loading parts that aren't immediately visible, prefetching resources likely needed next, tree shaking dead code. Using modern, fast build tools like Vite,
And for SSR?
mitigation often involves moving rendering closer to the user with edge-side rendering, ESR, on CDNs, using techniques like partial or progressive hydration to send less JavaScript initially, streaming HTML so the browser can render incrementally, and of course, sophisticated caching strategies are non-negotiable. And it's worth repeating, performance isn't just SPA versus SSR. How granular your MFEs are and how well you manage shared dependencies using tools like module federation significantly impacts bundle sizes and composition overhead, whichever route you take.
Performance is huge, but for public sites, you need people to find you. SEO. How does the rendering choice impact discoverability?
Pure client-side SPAs have historically struggled here. While Googlebot got much better at running JavaScript, relying solely on that isn't always foolproof or fast enough for indexing. You generally need some kind of pre-rendering or dynamic rendering setup, essentially. Having a server generate HTML specifically for bots, or using SSR as a fallback to guarantee good SEO.
And coordinating SEO best practices across many independent SPA teams sounds like a headache.
It really is. How do you ensure every team consistently adds the right meta tags, structured data, canonical URLs, all that stuff within their client-rendered MFE? It requires really strong governance or shared tooling to avoid inconsistencies.
So how does SSR help with SEO?
It's just natively friendly. The server sends content-rich HTML. Crawlers get what they need immediately, reliably. Faster indexing, better understanding by search engines, and that server-side composition layer makes consistent SEO implementation much easier. You can enforce standard titles, descriptions, OG tags, etc. centrally. It takes a lot of burden off individual MFE teams.
Any counter-arguments or nuances here?
Sure. SPA folks will rightly say that for many apps, internal tools logged in experiences SEO is irrelevant. And for public parts, you can use pre-rendering or static site generation, SSG, just for those sections, without needing full SSR everywhere. Hybrid is key. But the SSR counter is that relying on bot.js execution is still less predictable, can hurt your crawl budget on massive bytes, and the coordination problem for client-side SEO across teams remains a real challenge. And a really important point from the sources, not all MFEs in a big system are public-facing or need SEO. Think admin panels, user settings pages. Applying SSR everywhere might be overkill, adding complexity and cost unnecessarily. This really pushes towards using hybrid strategies intelligently.
Okay, let's shift focus to the people building these things, the developers. What's the developer experience, the DX, with these different approaches?
For SPA-based MFEs, developers often find local development simpler, at least initially. You can often run your MFE in isolation, maybe mocking the shell or other MFEs, or consume deployed versions of dependencies while working locally. This really fosters that sense of team autonomy. And since it all runs in the browser eventually, debugging feels kind of unified, using familiar browser dev tools.
Working in isolation sounds good, but does it hide integration problems?
It definitely can. The really gnarly issues often pop up at the seams where MFEs interact. Sharing state, routing coordination, UI inconsistencies. These might only appear when you assemble everything together. So debugging those cross-MFE integration issues client-side can get complex fast.
How does the SSR developer experience compare?
It's generally seen as more complex upfront. Local setup often requires running a mock server orchestrator. You have to write isomorphic code that works in Node.js and the browser, which adds cognitive load. Debugging means potentially looking at both server logs and browser consoles. It also usually means tighter coordination with whoever manages that central composition layer. This helps consistency, but can be a bottleneck if that platform team is slow. The upside, though, is that server layer makes it easier to enforce those cross-cutting concerns consistently, headers, footers, meta tags applied via server templates.
What are the biggest developer frustrations mentioned for each?
SPA devs often cite the pain of SSR's isomorphic code, server-side errors, and tricky hydration bugs. SSR devs frequently complain about dependency hell in complex SPA setups managing shared libraries, version clashes across MFEs, and they stress the difficulty of debugging those runtime integration issues, like shared data flows or router problems between different client-side MFEs. But honestly, the sources emphasize that good DX really depends on the quality of the tooling. Whether it's single SPA and module federation or Next.js and Nuxt, if the tools are mature, well-documented, and abstract the complexity well, DX can be good either way. Bad tools make any approach painful.
Moving beyond development, what about keeping these systems up and running? Operations and scaling. How does the choice impact that?
With SPAs, a big plus is hosting those MFE assets independently as static files. Deploying to a CDN is operationally simple, cheap, and scales automatically. This simplifies the CI/CD pipeline for each MFE team. Build your static bundle, push it to the CDN, that promotes agility.
Simple deployment sounds great. Is there a catch operationally?
Yeah, the deployment is simple, but the runtime integration is complex. All that orchestration, discovering MFEs, loading them, mounting them, version management happens live in the user's browser. So while deploying individual assets is easy, you need strong strategies for integration testing and managing version compatibility at runtime to avoid operational surprises when independently deployed pieces don't play nicely together. The complexity shifts to the client.
Okay, and SSR operations.
SSR gives you a clearer central control point, the server-side or edge UI composer. It's one place to monitor, scale, and troubleshoot the initial page assembly. This can lead to more predictable behavior, at least initially.
But doesn't that central point risk becoming a bottleneck or single point of failure?
Absolutely. If that orchestration layer isn't built for high availability and scalability, it's a major risk. Plus, you have the general operational overhead of managing a server-side rendering fleet Node.js runtime updates, deployments, scaling the servers, and especially complex cache invalidation across services. Though, as we mentioned, moving SSR to the edge with serverless functions is a growing trend to mitigate the central bottleneck risk, trading it for the complexity of managing distributed edge logic.
Any final operational trade-offs?
SPA Ops struggles with debugging those tricky client-side interactions across many MFEs and managing shared dependency versions deployed independently. SSR Ops focuses on managing the server infrastructure, caching complexity, and potential TTFB delays from slow orchestration. Good tooling module federation, single SPA for SPAs, serverless, good CDN caching for SSR is crucial for managing these operational challenges either way.
Architecture, performance, SEO, DX ops. Okay, let's bring it back to the end user. What's the user experience like? How does this choice feel?
SPAs really aim for that fluid, app-like feel. After the initial load, moving between sections feels seamless because there are no full-page reloads. State can persist easily on the client, but getting this right requires careful state management and communication between MFEs. That lack of page flashes during navigation is a big perceived UX win for SPAs. But you need smart loading strategies, prefetching, code splitting to make sure that initial load isn't painfully slow and the subsequent interactions feel responsive.
And the SSR user experience.
SSR's big win is the fast first paint. Users see content quickly, which feels responsive initially and is great for engagement. The potential downside is that navigation can feel heavier if every click means a full server round trip. But most modern SSR setups hybridize this. They use SSR for the first load, then hydrate into an SPA for faster client-side navigation afterwards. SSR also makes it a bit easier to ensure shared global state, like login status or shopping cart info, is consistent on first load because the server can inject it directly.
What about UX frustrations?
SPA critics point to that potentially long initial load time, the spinners, or maybe jankiness on slow networks devices. SSR critics point to the clunky feel of full-page reloads if not hybridized, or that weird uncanny valley where content appears instantly but isn't interactive yet during hydration. But ultimately, the sources stress that the overall MFE user experience depends on more than just SPA versus SSR. It's about how well you handle loading states, error cases, consistency across MFEs, and maybe even version mismatches gracefully. The composition strategy matters immensely.
Okay, we've covered a ton of ground on the differences and trade-offs. So, based on all this, When does one approach generally seem like the better fit for an MFE system?
The consensus seems to be SPA first with client-side composition really shines when SEO is not concerned and you need rich, complex interactivity. So internal tools, admin dashboards, authenticated SaaS apps where users log in, these are prime candidates. Multi-tenant apps needing lots of customization also fit well. As one source said, not everything needs Google indexing it.
And where does SSR plus MFEs typically make more sense?
SSR is usually the go-to when that fast initial load and solid SEO are business critical. E-commerce is the classic example. IKEA, Zalando were mentioned. Public portals, content-heavy sites like news or media outlets. Anywhere getting content seen quickly and found easily is paramount. One source mentioned e-commerce teams specifically choosing Next.js for its SSR capabilities. It really boils down to what's the main goal? Instant content and discovery. SSR rich, dynamic interaction for known users. SPA. And, of course, team skills and structure play a huge role, too. Technical purity doesn't help if your team can't build or maintain it efficiently.
All right, the human factor. And the fact that many large systems have both public content and interactive logged-in areas really points towards needing more nuance, right?
Which leads us back to hybrid.
Absolutely. It seems like for many real-world large-scale systems, picking just one side of the SPSR divide isn't enough. Talk to us about these hybrid approaches.
Yeah, hybrid is where things often land in practice. It's about pragmatically mixing SPA and SSR techniques to get the best of both worlds where it matters most. Often this means using SSR for the initial page load to get that fast paint and SEO benefit, and then hydrating into an SPA for smooth client-side navigation afterwards.
What are some common hybrid patterns people are using?
One way is an SSR shell with client-side MFEs inside. The server renders the basic page structure quickly, then the browser loads and mounts the interactive MFE components, gives you fast initial paint plus MFE team autonomy. Then there's the islands architecture idea, which is gaining a lot of traction. Frameworks like Astro and Quick champion this. The idea is most of your page is static HTML, delivered via SSR or SSG. Only small, specific interactive components the islands get client-side JavaScript. Minimizes JS, great for performance and SEO. Quick's resumability takes it even further, aiming to skip hydration altogether.
Interesting. So opting into JavaScript instead of defaulting to it.
Exactly. Another common pattern is deciding per route or per MFE. Use SSR SSG for your public marketing pages or blog MFEs, but use a client-rendered SPA approach for your complex authenticated dashboard MFE. Frameworks like Next.js make this per-page decision really easy, and you can combine it with module federation for the MFE parts. Angular is also moving in this direction. And we touched on Edge SSR with client orchestration. Render the initial view at the edge for low latency, then let a client shell handle further dynamic loading and interactions. DAZN's setup sounds like it might involve elements of this.
Are there big companies successfully using these hybrid model?
Yeah, several are cited. Zalando's project Mosaic and Taylor for server-side composition, DAZN with vertical MFEs and edge deployments, Spotify historically using client-side composition, iframes, event buses, IKEA using ESI for edge composition. The common thread, though, is that these sophisticated hybrid setups often involve significant investment in custom tooling and dedicated platform teams to make them work smoothly at scale.
So what's the quick summary? Pros and cons of going hybrid.
Pros. You can get a better balance, fast initial load and fast subsequent navigation, good SEO where needed, flexibility to use the right tool for the job. Targeted optimization. Cons. Complexity goes way up. Designing, building, debugging, and operating hybrid systems is inherently harder. You need mature tooling, skilled developers comfortable across paradigms, and robust operational practices. One source mentioned developers getting bogged down by caching and rendering inconsistencies in hybrid setups. It's a real challenge.
It sounds like a constantly evolving space. What are the big trends or future directions we should keep an eye on?
React Server Components, RSCs, are a huge one in the React world. They let you render components on the server without adding to the client.js bundle. This could enable near-zero JS MFEs for certain things, really pushing that islands idea and blurring the server-client line further. Integrating them smoothly into MFE frameworks is the current work in progress. The shift to edge computing for SSR is definitely accelerating. Rendering logic on CDNs close to users offers compelling performance benefits. We might see MFEs become even more granular, like individual edge functions. Managing that distributed complexity is the trade-off. We'll also see continued innovation in the core MFE orchestration tools, single SPA, module federation, Server-side composers like Tailor or Isomorphic Layout Composer, they're always aiming to improve DX, performance, and manageability. And fundamentally, the big meta frameworks, Next.js, Nuxt, Astro, Quick, are increasingly being built as hybrid-first platforms. They bake in granular control over rendering, so the debate is less SPA or SSR and more, okay, how and where do we strategically mix these within this framework?
Okay, let's wrap up this deep dive into the SPA versus SSR debate for microfrontends.
We've seen SPAs really shine for team autonomy and interactivity, great for internal apps or SaaS where SEO isn't the main driver. And SSR excels for initial performance and reliable SEO, making it a strong choice for e-commerce or public content sites.
But for many large, diverse systems, neither pure approach is quite right.
Exactly. Hybrid emerges as the pragmatic path, letting you mix techniques, maybe SSR for the first view, SPA for interactions after that, to get the best of both worlds where it counts.
And a really key takeaway is that the right answer isn't fixed. It depends heavily on your specific business needs, your users, your team skills, your performance targets. It's very contextual.
Totally. And maybe the final thought to leave you with is this. Success with MFUs, regardless of your rendering strategy, probably depends less on picking the single perfect approach upfront and more on building the capability to adapt. It's about strong governance, managing shared standards, investing in your platform tooling, and continuously refining your approach as needs and technologies evolve. The real win is in taming the complexity, not pretending you can eliminate it.
Taming the complexity. That feels right. An ongoing journey.
For sure.
Well, thanks for joining us on this deep dive. The world of web architecture never stands still, does it?
Keeps us busy. Stay curious.
And make sure you subscribe to The Joy of Architecture so you don't miss our next exploration.